Before we get started, I want to introduce Councillor Aquilina and Councillor Bodner, your Ward 4 councillors. In case you don't know them, that's them. I'm Alana Vanderveen, Drainage Superintendent here for the city. And this is Paul Marsh, the engineer appointed to create a new report for the Oil Mill Creek. Oil Mill Creek Municipal Drain. So before we start, I just wanted to bring to your attention or ask that if you have any questions regarding the billing that you recently received, if we can leave those particular questions to the end. I didn't see any pitchforks, so I'm excited about that. But we'll let Mr. Marsh do a presentation. It'll take probably about 20, 25 minutes, maybe less, depending on how quick he speaks.
Maybe more.
Maybe more. And just to point out to your attention, on the back wall, the glass sliding doors back there is a draft copy of what Mr. Marsh has put together for this particular drain. And before we turn it over to Mr. Marsh, women's washroom is on that side, men's washroom is on that side. And I also wanted to let you know that I am recording this. I didn't have intentions of doing that in the beginning, but should one of your neighbors want a copy of it or know what happened, rather than you trying to say, oh, this is what happened, just watch the recording. I'm hoping that it'll be on the website by Friday. It'll be under, if you go onto our Colborne website, there will be a section called Living Here. Drop down, there will be a section for municipal drains. Scroll all the way down, it's going to be down in that bottom stuff. And I will turn it over to Mr. Marsh.
Thanks, Alana. I have too many slides. I'm the drainage engineer appointed by council. I was appointed 3.5 years ago, so I'm very excited to be at this point finally. This is the second public meeting. The first one was held, I think, in 2021 during COVID, so it was held remotely. This is our first opportunity to have an in-person meeting to discuss where we're at. And so this is what we've set up. I'll talk about what we talked about last time, even though some of you may not remember that meeting. I'll talk about what we're not going to do. I'll talk about what we're proposing to do, and then talk about next steps as the last part. And if you have questions, or I'm going to go through the slides very, very quickly so that we get to the end. And then if you want, I'll back up to any slide that you have a specific question for. This is where we are in the process. This is Public Information Center number 2. Our goal is for me to deliver a final report to council for them to consider it. They hear it 3 times and it gets passed as a bylaw. We do the work, it gets billed out. That's the general scheme of things. All the stuff on the right-hand side is the approval process once the report is done. Right now, if you have specific concerns and I can fix it before the report goes to council, that's the purpose of this meeting, is for me to hear what you would rather have or would like to see different. And we try to accommodate everyone's views. We can't accommodate everybody's views, but we try. We did do a baseline report. The baseline report looked at what's already there, looked at the problems, and this is supposedly looking at solutions. I'll tell you what I think solutions are, and you can tell me whether you agree or not. This is just looking a little bit at the survey elevation versus the original report from 1977. And so the survey, we're a little deeper than the original 1977 report, but I'm converting that from feet and inches. And so there's a little bit of funny business from 1977 feet and inches to metric. So it's important to look at the general shape rather than exactly where those points are. What you'll notice is that this drain is not a straight drain that goes from the lake and straight up and ends at a bunch of farmers' fields. There's a lot of different pieces and parts. E1 branch, I was going to point at the screen, but I don't know how to do that. There's no, yeah, thanks, Alana. E1 branch runs up and goes backwards to the east. The main drain goes straight north up to the Friendship Trail. The west branch does this southwest wiggle that goes out past Pinecrest Road. And E1 and E3, E2 and E3 are off to the right by Cedar Bay Road. This is just looking at the relative slopes. And as you go north, E1 and Cedar Bay and Oil Mill Creek, Maine, they increase by 2.8 meters over their length, which isn't bad. Port Colborne's not famous for having a whole lot of slope to the lake. Some parts are pretty flat. Wignall Drain is 2 kilometers with 0 slope. So in comparison, this isn't too bad, but you can see that the west branch, the blue one, that's the 0.64, it's not got a lot of slope. It's what we would call terrible for slope. There are wetland features that exist in the drain. And again, when you have kind of compromised slopes, there's wetlands there. The benefit for us is the drain existed before the wetlands. If we go forward and say we want to drain in a wetland, generally that's hard to do now. But if the drain exists before the wetland, then we can go in and do maintenance and make changes. But there's limits to what we can do and get approval for in an existing provincially significant wetland. So we set up a computer model and we analyze how this thing performs. The surveyors do cross sections and we calculate whether hydraulically it will pass enough water or not. And we build a computer model and it looks like this. You know, it gives you a profile of what the depth of water is going to be at different points in the watershed. And the reason we do that is to find out what the problems are. And I think there's a slide coming up here, but one of the issues is that West Branch is so flat that its water arrives later than the water from the upstream parts. So by the time it goes to go out to the lake, everything's already full, is what the basic computer model. And all of you will say, I could have told you that. You don't need to build a computer model. But we do the computer model because as engineers, that's what we like to see analyzed. Maintenance has been performed, as Alana said, 2008, 2011. But again, in subsequent years, well, you guys know what the maintenance was done. Culverts, there are a few structural defects, some that are rusty or at risk of collapsing. We've identified those for replacements. Some culverts are not quite as big as they should be. And so we identify some that should get installed a little bit bigger. The winch that controls the flap gate is a total manual affair. You have to walk out and stand on top of the outlet in order to operate it. And when the water was much higher 2 years ago, that was a little dicey at times. If you were late getting to it and the storm was already on, it was a tough place to go and operate the winch. So drain issues, the outlet gate. Bell Acres has problems in roadside swales, standing water. The West Branch, this goes back to the very beginning. When it was first created, everybody knew there's a rock hump in it. The original engineers identified on the plan to put clay in to try to level it out so it would drain properly. And E3 branch has some bank erosion and there's a culvert issue. And there's flooding in Centennial Park. So those are some of the things that we looked at. And these are some of the things we looked at and we're not doing, which maybe that's a funny way to say things. But we looked at things, we tried to find a solution and it didn't quite work out. That's these things. So I'm going to have to, I'll actually come around here so that it's easier. Start at the very top. Whether we could do 2 new outlets. The existing outlet is a steel pipe and then a concrete pipe that goes out to the flat gate that's an outlet. And it's flat. So the water has to get to a certain height to drive itself to the lake. And it has to actually get really full. And I've got another slide showing this for it to be a full pipe. It's very difficult for the pipe to run full. So we looked at whether we could do what's called a diversion. When the water gets to a certain height, it has another path it can take to the lake. This runs through the middle of the park. And then there's this one over here. And the trouble is the one through the park, if it's an open channel, it's massive. It's like 10 meters across the top because of the way the sand is to go out to the lake. And if you use a pipe, well, it's not a path we can take without losing trees. So there's a challenge. And the pipe's not cheap. So these, they do work, but you know, you're looking at $250,000 for either one of these to go ahead. So we said no. We looked at changing E1 to go straight down into the park. And when we surveyed this, it looked good. And we analyzed with the computer model, it looked good. And we talked to the farmer up there that owns the farm, Mr. Vander Vaart. And he says that'll never work because there's an outcrop of stone runs through the bottom part of that farm. So we went and we pounded a steel rod in and measured where the stone was, and yes, if an old farmer who's lived there for 50 years tells you something, you can pretty much believe it. And he's right, there's stone there, we could still do it. The stone makes it expensive to do it. We looked here at C, this little wiggle at the north end of Mercy. And we looked at Merkel, thank you, Elena. And we looked at B, and those shortcuts kind of help, but they don't do a whole lot. Like they're okay, they're just not a great cost benefit. We looked at D, and D is a roadside swale. It's not part of the drain. We looked at whether we could make it work by choosing a different outlet. And the reality with all the culverts that are in there, it's better to stick with the outlets that's there and just shape the channels so that it gets to the outlet. And I've got a slide to show how that looks. We looked at the very, very top along the Friendship Trail, and there's not a huge benefit to doing that. The connections that are up there, and I'll show a proposed drain. So the part that we did do is the one that's west along the subdivision. There's already a channel there, but there's a way, and it's in the report, and I'm talking about it tonight, how we make it part of the municipal drain. I think that's it. So the ones, what we'll talk about is what's next. So this is the one that goes up and to the right. There's flooding at the back of these lots, and this does solve that. But there's no way for me as an engineer to make this go forward. I need a petition. Someone has to sign a petition to say they want this drain. And so if you live in here and you're interested and you can get half of your neighbors to say yes, this could go forward and be part of this project.
Tell us more specific. Yeah.
We're hard to see.
Okay,
This is Merkel Road.
Yeah.
And this is Cedar Bay Road.
Where it goes up, what's the top of the shading, like at the other end.
I don't know what the address would be.
Okay.
That looks like John Schneider's land.
That's not here, so
I
they-
think so. The top.
Oh, that makes sense. Because it was the top of the right. Yeah,
Okay.
okay, that makes sense, yeah.
Does that help?
Yeah.
Is there not a house in the back there? Like between one and one, right?
Behind.
This used to be Bar Talk.
Yes, that's perfectly. Yeah, that's all we know.
So you have an access off of Cedar Bay as well?
Oh, yeah, there's no access there, but like it's, like my property does first.
Okay.
There's no driveway.
yeah, so this as a proposed catchment goes to where his property
Touches Bay Road. We're just, that's kind of the basic part of it.
And the trick here is if we went to the road, then she could sign the petition and it can go forward. But in this case, the road's already serviced by a roadside swale and it works. So we can't really get the road to sign a petition. You'll see with the subdivision, we're using her as the road authority, and I shouldn't say, Alana's being the road authority and is signing the petition so the other parts can go forward. But in this, we really need all the neighbors to agree. And under the act for a new drain to be extended like this, you need at least half the owners, 60% of the land. And they put this in the Drainage Act because in some cases you'll have a farmer who wants something to go ahead or doesn't want it to go ahead. And there's 10 other properties who do or don't want it to go ahead. And the act has those 50% of the landowners sign the petition. It goes forward, representing 60% of the land. And so this one is one that's actually not going because we don't have a legal basis under the act to push it forward. And this is about petition drains and C, where it's required for a road at the request of the road having jurisdiction. The other one here is the D is by the director. I don't understand who that is under the act. I assume it's the minister or an appointee, but I haven't seen one where they've actually exercised D. We did analyze returning the pumping. If anyone's been near the outlet, there's a little oval tank off to one side. In the 60s, I think it started being pumped and there's a discharge pipe. We analyzed and estimated what the cost would be to return it, not replacing the pipes, keeping the pipes as they are. But I'd be concerned about whether they would survive a new pump or not, because the pipes are rusty and old, but sometimes rusty and old pipes are still okay. We didn't analyze whether the pipes would hold together. But it's like 135,000 to put new pumps in there to bring three-phase power from up at the intersection is basically where it is, down. We had a quote from Fortis for what that would cost. And so the pump pulls from the pipe and then pumps through the little rusty pipe out to the outlet. And it's just not doing enough the way it's set up in the 60s with the big steel pipe that's extended to Vimy Ridge Road to be that much of a benefit. If you're going to spend that much, you might as well reconfigure a whole pumping system to pull from where it's open, not piped, and have a whole new path that goes to the lake. But it'll be more than that. And so we've analyzed this. There's a small benefit. Personally, I'm not sure it's worth it. But again, with this report as a preliminary report, if the people who were in favor of pumping, 50% of them sign a petition, then council has the basis to make the pumping be returned. Because when you sign the petition, you're saying, I support spending $135,000 to have pumping go back. So what we are doing, and in my search through this presentation, I found this letter from 1978. It's to the city engineer at the time, and it's about what they looked at back in 1978. And not surprising, a lot of it's the same stuff that I'm talking to you about tonight. And the difference is in 78, they didn't do anything. They looked at a new outlet to the lake and they decided it was cost prohibitive. They looked at changing the flap gate to what's called a knife gate or a sluice gate. So instead of opening and closing, it goes up and down. And the problem is someone still has to make it go up and down. And so in my view, it doesn't work any better than one that open and closes. There was flooding along Cedar Bay Road, and they said if somebody petitions for a new branch, that could go ahead. What we just talked about. Flooding around Vimy Ridge Road, and they looked at an outlet through the park and said it would be too big of a channel. The outlet through the park, if it's a pipe, it's reasonable to see it could go. It's still going to cost a significant amount of money. And the last one, they looked at the detention area and they calculated it would need to be 18 acre feet, which for me, metric, 22,200 cubic meters, which is massive, way bigger than what we could fit in the park. So we have analyzed and recommended putting in a wetland, but it's not that big. So control structure considerations, we talked about pumping. The existing pump structure hasn't operated for a long time. It's possible to put it back in service. And, you know, I can't tell if the pipe that draws water into the little oval, it's got rust in the bottom. Mostly it's okay. And the pipe over the top, it's rusty, but it's mostly okay. But you could run it for a month and then break something, and then you're stuck fixing and replacing the pipe. Control structure, runoff flow through the openings, 1 in 100 year storm. It's a big pipe. There's a storm surge, so the gate closes, but it's on a winch. We looked at modernizing it. We have some other modernizations at other places in Port Colborne. So there's comparisons. This is what the computer model says happens in the outlet. And so I'm going to just point out a couple of things to orient yourself to here. Penny Ridge Road. So this part, it's a rectangle. That's where it goes from open and crosses the road. The other side, right through here, is the steel pipe that was put in 1999. The concrete's this last little bit. The last little drop here is the outlet. This is through the park. These are the twin culverts that are the laneway in the park. And so what happens is, if we want the pipes to be full of water, the park has to have, yeah, the park has to have 5 feet of water in it for the pipes to even come close to being full. And that's part of the challenge with the outlet. It's big, but it's tall. And what you need is more width to have enough capacity. Even though the pipes are ellipsoids, right? Like they're wider than they are tall. It's still a challenge to get the park deep enough to run full water. Let me see. Yeah, so this is Alana's picture. I think it's Alana's picture. It's from February 28th. We had a little mini melt. And so there was a whole bunch of water running out. The park, you know, like it was full. She didn't get a picture of the park to compare, just the outlet. But you can see the gate's wide open and you can see it's running and it looks kind of like the computer model. It's running really, really well, but it's not full. It's not even to the midpoint of these ellipsoid pipes. This is what you don't like to see. The gate's closed, but there's water that wants to get out, right? And so we did a calculation, basically with all the steel that's in the gate, it's 1,000 pounds. And so unless the water is pushing with 1,000 pounds pressure, it won't push the gate open. So one of the things we looked at is what can we do to the gate? And we can automate it. Instead of a winch, we could computer control. It's a lot of money. I'll show you what we got a proposed solution. I'll show you in a second. But these dots, it goes back to how deep the park has to be. The deeper dots are 175.5 to 175.75. So it's kind of, once the park channels go above and it starts to spread out, and I should point out what the dots come from. The dots are from 2012. They flew an airplane over and they give me a dot every 10 meters with the elevation that the airplane picked up. And it's like plus or minus, they say it's plus or minus 20 centimeters, which is like this. So it's not as accurate as the new data that's available. The new data is 2 centimeters accurate, way better. But this is what I had as the 2012. And I'm coloring each dot based on how deep the airplane says that dot is. So the color represents where the water's deeper. And if it's 176, which is, this is the flooding we would expect to see, and the pipes are still just barely running full. They wouldn't be running full, even at this depth. So in our model, we actually do consider how much water sits in the park. We look at how fast it tries to get out, how much water sits in the park, how much water is coming down from the north. That's the benefit of what the water model is telling us. This is the same as before, slightly different color, but the blue line is 176. So it tells you the extent of what flooding would look like to 176. And that's, these was, we looked at the outlets. This C, there's one more. This is the existing, whether pumping would improve is D. C is whether a wetland would be useful or not. This is what the outlet looks like. That's the discharge pipe. I'm just going to go to this and explain. So these are the two changes that we are recommending that would benefit. And number one is move the winch from on top of the outlet back to where the stairs used to be. So when I started this, there were stairs. Last time I was out there, there were no stairs. But now there's a concrete pad there. So we won't use the same winch. We'll replace the winch. But instead of somebody having to go out and stand on top of that, it can go where the stairs used to be for anybody. And the other part we said is, the power guys said it's relatively cheap to bring 110, 120 power and put it up where the oval is, right there where I've got that top red arrow. And so we could have a winch that's powered. It's not that expensive to have a powered winch, and then someone puts a button, open and close. If you could just hold it until we get to the end, and I'll come back to you. Thank you. And the last part is, if the gate's closed, but there's water that wants to get out, we're proposing in these two middle panels that we cut a 1 foot hole, 300 millimeters, both of these, and we cover it with a polyethylene flat gate. These are stainless steel angle bars so that the polyethylene doesn't push back in through the opening. It's not as big as what we would like. We'd like the whole gate to move open and closed when there's enough water. But at least when water is built up and it will go out, it will push these little light gates open and go out. We're saying just two, but if it works, we could put more in. But these two wider panels are the easiest to deal with. And it'd be nicer if they're along the bottom. But because of the oval pipe, these are not as useful as you might think. So maybe this would be the next spot for it. And it's better if the gate were open when it's supposed to be open and closed when it's supposed to be open. So the other thing, we didn't include this, but we had proposed a sensor that would tell the operator whether it's open or whether it's closed. Because where it used to be, the operator could walk out and look underneath and see what it was. But once we move it to the back, it's not as easy to see whether you're all the way closed or all the way open. I'm sure there's ways on the winch we could put flags so they would know. So, okay, Bell Acres. This is the original lot drainage plan. And these are the 3 road petitions to convert the existing channels that are there into municipal drains. That's the process. Doesn't have to be 50% of the owners. The road can ask for sufficient outlet, is what the legislation calls for. And what I wanted to say is, under the act, I have to follow what the act says in giving allowances. But this would have been better done when it was subdivided. Not now, 10 years, 15, 20, not later, right? Because at that time, the developer would have paid those allowances and assessments. Now it's shared as a group, that the allowances are direct to the property owners or where the drain sits. So they get paid, but really the original developer should have paid for everything. This is what we're proposing to help Bell Acres. And Bell Acres comes with 2 parts. Part 1, this is E1 and it's going out to Cedar Bay Road and everything gets deeper. We changed the shape of the drain grade in order to lower it where it goes north along the side of the Bell Acres subdivision.
Go east, not north.
No, north. Let me go back.
Shows. What is that?
Okay, so the next slide is the part that goes up here and across here, the original E1 branch.
Okay.
So I have to lower E1. I have to lower E1 first. If I can make any improvements in the ones that goes north and east. Right? And so if I can get E1 to go down, then I can improve this. If I can't fix E1, I couldn't do anything. And originally, we looked at doing this by connecting this straight through the park. And that looked really good until the rock was pointed out. And so we went back and we said, what do we have to do with E1? Make it work better. This part is actually in the wetland. And so there's no point making it deeper in the wetland. It's already a wetland. And this is the private road that's going back along E1. We start there and there's this is E1 and these are twin culverts, yeah. So these ones will have, there's two culverts there, relatively new ones, polyethylene. They'll have to go lower in order for this grade to work. And I don't know if you can see it, but this line going through here is the original engineer's line, and it's a straight line. And so this, you know, it's gravity. It's not a genius engineering anything. I'm just lowering the middle so that it's deeper and slower at the bottom, but I get an improvement through the top. And the main improvement is right here, where there's a connection to Bell Acres. That's what this looks like. This is that same connection to Bell Acres. And I'm lowering by basically 8-10, almost a foot through that west side of Bell Acres in order to get an improved drainage. There's one caveat in all that. We didn't check that for rock. There's rock not that far out there. So I'm hoping 8 or 10 inches is okay, but we could run into rock through there too. But, you know, 8 or 10 inches is an improvement. It's an improvement, but it runs it faster to the bottom. And that's the second part of what Bell Acres has to accept. Under the Drainage Act, there's a benefit and what's called an outlet liability. So you get a benefit from the drain, but you're liable for what your water does downstream. So what we do is, this makes it run faster. It's better. It's lower. It's better. But it makes it run faster, which isn't good for your neighbors that are downstream. So generally, in engineering, when we have a subdivision, we call it controlling post-development flow to pre-development levels. And I'm not getting that here. It's too difficult to do that afterwards. It would have had to be done at the time the subdivision was designed. But I'm putting a pipe in here that's too small. It doesn't pass all of the water. It's lowered, so it will make the water drain away better after the storm goes past. But the ditches, the channels will fill with water. It will slow the water down in the subdivision and let it out over a longer time to an 8-inch to 10-inch deeper level. And then I can have a better picture. Well, this is just what the computer model says. It's composed of a pipe, and then there's an overflow swale on the top. The overflow swale is set up so you can run the lawnmower through it, and it's 8 to 12 inches deep. So once the pipe in a big storm is running as fast as it can go, it flows over the top into the channel on the other side. It looks like that in the diagram, right? This is the pipe. It's 30 centimeter polyethylene pipe, smooth wall in the end. And it's lower. It runs all the water off eventually, but it causes it to slow down. And then there's 3 of them in all of the road petitions. Each of them, you call the top one
Richard.
Oh,
Yeah.
Tracy. Tammy. The top one's Tammy. It's Tammy doesn't actually get to it, but it's all its water that's going out there. Richard's the one that goes through the middle, and Tammy Terrace is the southernmost one.
Tracy.
Tracy. This is what it looks like from the computer model, and I'm showing this because it comes in with the peak and it's knocking the peak off. That's what we want to get out of the pipe. Is when we don't control anything, we get this really sharp peak. The water rises quickly and it goes back down quickly. This is spreading it out to a longer duration. And besides that, that's all I can do simply and cheaply, is to put in a too small culvert that backs water up with the storms, lets it out slowly. But each of the property owners there can do measures on their property to slow runoff down. You can direct your downspouts into what's called rain gardens. Infiltration trenches, I put that up there because we always say it, but there's so much rock up in that subdivision. I don't think infiltration is a really practical thing to try to do, but anything that slows the water down is a benefit. If you want to look at this and Google it, you can Google the Sponge City Initiative. This is one of Montreal's things. They want the water to slow down. So they want it to be soaked up by their landscape, not have it be so hard and just run off quickly. Everything's about slowing the water down. Now I'm going to talk about the West Branch. And the West Branch is a pretty simple message. This is the proposed grade line. And this is the rock hump. We're going to take the rock hump out. It's not easy, but the machines are better now. They run on a hydraulic thing. You break it up so there's a drain point that matches the grade line, so the water gets away. And then kind of the only part that's not great is all the people that have to lower their culverts so that they match where we end up. Some of those culverts were too small anyways, so we're making them a little bigger as we go. E3, it was a horse paddock when I was there. Yes. The culvert that's there is kind of messed up, so we're putting in a new culvert. Not as deep, but it has to be reconstructed. And the channel goes in as a low flow channel with rock and then a wider channel up above. The hope is that the low channel drains it out so that the wider one keeps its shape. But it's really the low one with the little rock bank that should keep its shape. And then there's where the fence is, we want to make that an access point. Does here, yes. When we've talked to MPCA about this, and they were okay with it, which I was kind of surprised. But E2 and E3, original E2 connected right on this bend. And so part of it is pointing backwards to the way the drain goes. So we're proposing to realign it to this point so that everything points to the outlet. It's not a big thing, but it is a better geometry for the flow to get to the lake. So this is part of the Centennial Park, and right where the culverts are, where the rock comes out of the West Branch, we're proposing to reuse it in that area. The culverts, the bottom of them is deeper than the lip at Vinnie Ridge Road. So there's no way for those culverts to run the water that's in the bottom out because they're deeper than what Vinnie Ridge Road will let go. And so these riffles, now they don't create any capacity. All it will do is change the water quality. Right now the water sits and the riffles will alternate between a pool and a shallower area so that when it runs, it just alternates between there. And it's not a massive benefit. We're just going to use the rock that comes from the West Branch and do 1 or 2 riffles on the upstream side and what's called a plunge pool on the bottom. So it looks like this, where the culverts come out. Generally, we would do this because it's better for the fish. But the Department of Fisheries and Oceans has rated this and said it's not a concern for fish. It's because of that flap gate. There's not really fish habitat behind the stream, which is a benefit for Alana, because whenever you want to do something and there are fish in the drain, she has a lot more work to do. That's the case. And this, it's just that little part. And this is the proposal for the wetland. We changed that shape a little bit, but it comes in two parts, the west lobe and then the east lobe. And the original part that was better, when we ran it in from the north, it ran in from the top and it ran out the bottom. And that's a nicer geometry to fill it than what we're doing now, because we're not running from the top anymore. Now I have to fill it back. The water has to get high enough here that I fill the wetland. And with the grades not being great, it's a little tricky. But this is what has to happen. This green line is the wetland. And so I'm trying to make it flatter than the west branch. And I already showed you how flat the west branch is. But the idea is to get the wetland to fill before the west branch gets full. So when the water comes from the north, it goes in the wetland, and then the west branch can actually have space to get its water across. The model says it works, but it's a computer model. So the proof of the pudding of this is when it actually does work. I don't want to say I don't believe computer models, but there's a limit to what it will really actually tell you. And in this case, we're trying to give the water space to go so the west branch can get out. But there's going to be a really big storm and it won't matter. Everything will fill. The storm we're talking about is 68 millimeters of rain in a 24-hour period. The whole report is based on hitting that as a target. But we had a storm July 17th, 102 millimeters in 14 hours. And we were out surveying the next day. We heard a lot of comments, but that 102 is bigger than what our design is for. So yes, everything will still flood. This is the control, and we're showing a proposed bridge, a pedestrian bridge. There's no assessment, there's no cost for the bridge. If the city wants to put a bridge in, it's at their expense, it's their park. All I want to get is space for the water to go, and it goes in through this V-notch weir. So when it floods, it goes across this top part, and it will even go across above this. But then it doesn't come back out at the same pace. So it gives it space to go, and this holds it back and makes it a little slower to go back out through the outlet. It looks like this. I got 3 slides. This is when it's filling through that notch. This is when it's all full. You can still see the water's quite high in through the park and above. And this is when the storm's passed, and now it's coming out. Some of that weir keeps it in forever. So we call it a wetland because the lowest part of it keeps water. Those hydrographs. This is the start of the computer analysis. The top part is what the rain looks like. It's shaped into a specific shape. And it's 68.9 millimeters in 24 hours. And then this is the runoff that shows up. This is E1, and you can see E1 is still pretty peaky. It's sharp. And this is Oil Mill Creek as it comes off of Pinecrest Road and into the Centennial Park. And then this is the West Branch. And this is the wetland filling backwards. the hydrograph's upside down because it's backwards. And I'll get this one too. These are the peak flows that are going through. And this hydrograph here is after the wetland. And it's, the wetland's doing what we hope it would do. It's knocking the peak off and releasing the water over a longer period of time. That's what we want to do. This is one of the more recent drawings and what it looks like. We've narrowed this up a little bit and, there's a culvert that's in the park. It moves to the north. This is the very lowest part. We actually surveyed some of the rock surface in there. And the rock is, I would have liked to have made it a little bit deeper. There's no point making this deeper than the rock is. So we've just said in here, go to where the rock is, and that's it. That's the path that fills. That's the lower wetland. That's the part that floods. And this is kind of what the whole flood would look like. And now this is the slide everybody's been hoping for, is the summary. Gate improvements, very simple, a new winch and a way for low flows to escape to the lake. Without the gate being adjusted, it's still better to open and close the gates on the proper timeline. A lower grade line to improve benefit, but controlled outlet is LA. Yeah, so the subdivision, they get an improved grade line at the cost of controlling the peak flow with the culverts. The west branch gets the rock hump removed. E2 and E3 has an improved alignment to the main. And there's channel changes in the Centennial Park wetland to give the water someplace to go rather than just flooding everywhere. And the last one is throughout the whole, there is still maintenance to be done. So the total of this is $623,000, $199. It's an estimate. Like I figured out what the winch is, but I'm guesstimating what it would cost to put it in place. And there's 227 in administration. That includes my costs, but some other costs are in there as well. And 15,000 in allowances. This is mostly payments to land that we're taking for the channels that are up in the subdivision. So even though there's a channel there under the act, I have to pay the person for the land that's being taken, because it's still their property. And then I have to pay the original construction cost less the maintenance cost. So there's a payment that's worked out and paid for that. This is what all those splits look like. And I don't expect you to read through all of this, but the most expensive part is some of the culverts and maintenance work in the upper watershed. There's a culvert to go in up there, right at the Friendship Trail. But I think the municipality picks up most of the cost of that new culvert. And the wetland, even though we're just, digging out a big hole, it still have some cost to it. All the spoil gets left on site. There's new legislation effective last year and into this year called excess soils. And if you move the soils off the project site, you have to have testing done. As long as we keep it within the drain limits, then we don't have to do the testing. Next steps. I finished my report. I get to hear whatever you want to tell me tonight. I try to accommodate that. The report goes to council. They allow it to go forward. There's a meeting to consider to finalize it. If anybody thinks they're paying too much for assessments and they want to challenge it, then there's a court of revision, which is councillors here. What your argument is to change the assessment. The council can then direct me to change the assessment. If people are still not happy, you can appeal to the tribunal. If you want to know how that whole process works, Alana or I can get you some information on how that unfolds. The ministry is working on a new homeowner's guide to the Drainage Act, which will also explain that. But there is information available that explains how that whole appeals process works. If you want to know, once the bylaw is passed, then work can commence.